we had looked at this Ferris wheel, and we knew that the center was at 30 feet. We knew that the radius was our 25 feet, and we found our height by using this 25 sine 36. And we used sine because this was the opposite, this was the hypotenuse. And then we added on that there was one revolution in 20 seconds. So we went all the way around in 20 seconds. So there's a couple ways that you could have dealt with this. You could have said, okay, well, there's 10 sections. So if I do 20 seconds divided by 10 sections, then that means that there's 2 seconds per section. So then this would be 2 seconds. Okay? And then another way that you could have looked at it is that you could have said, okay, well, we're going around 360 degrees, and that takes us 20 seconds. So then that is 18 degrees per second. Okay? That's one way that you could have got to the 18. The other way is that we know from the day before is that since there's 10 sections, that's 360 divided by 10, which gives us 36 degrees. Well, if 36 degrees was for 2 seconds, then 18 degrees would be for 1 second. So you could have solved that in a couple of different ways and looked at it. Now, depending on how you did the problem, there's a couple ways that you could have solved for this height here. So some of you might have done that this is 25 sine times, this would be at 2, 4, 6 seconds. So I would do 6 times 18, and then we would add the 30 degrees to that. So if we do 6 times 18, then that gives us 108. So this would be 25 sine of 108 degrees plus 30. Some of you might have looked at it and said, well, this is the same thing as, well, this is 36 and this is 36. So if I add those two together, that gives me 72, like we had done the other day, and might have done 25 sine of 72 plus 30. If we put both of these in the calculator, I check I'm in degree mode. So if I put both of these in the calculator of 25 sine 108 plus 30, or if I do 25 sine of 72 plus 30, we end up with the same thing. So what happens is that we have two things that now are true. We have sine values that have matching values, and we just took the sine of something larger than 90 degrees. So we have sine values that are larger than 90 degrees. Which we've not done before, because everything we've done before with sine has been in a right triangle, which means that it needs to be less than 90. So this is a new idea for us that we could have take the sine of something and have it be more than 90 degrees. So the difference between those two is that the 108 is looking at your angle of rotation, and then the 72 is looking at this angle here, which we refer to as the reference angle. So this is a new vocabulary word. So our reference angle is from the circle down to the center perpendicularly. And we had been using the reference angle the day before when we didn't have it in terms of time. We talked about how we could use all of this symmetry, and these four triangles were all 36 degrees. And then we looked at these four triangles, and they were all 72 degrees. So it made it really quick for us to find our values. That's when we were using the reference angle. So the reference angle is from the circle down to the center, down or up, depending on which direction, to the center perpendicularly. Okay. Now, if we look here, we had talked about the day before where we needed to decide if it was above the center or below the center, and then that would determine if we were adding 30 to it or if we were doing 30 minus that value. But if you had used the angle of rotation it actually did that calculation for you. So for example, let's say we take 14.5 seconds, which was one of the ones that you were looking at. So if we do 25 sine of 14.5 times by 18 degrees, because remember we're doing 18 degrees per second, and then we add 30, right? So if we go to our calculator, I'm just going to put in the sine of 14.5 times 18. And notice it gives us a negative value. The sign is negative because this was below the center. So we have this information now that if it's above the center, our sign is going to be positive. If it's below the center, that our sign is going to be negative, which should make sense because we had to subtract it off from the 30 the previous day. If I'm using the reference angle, I have to do that subtraction myself. So if we'd use the reference angle for 14.5 seconds, then I would have to decide that I need to do 30 minus 25 sine of the reference angle for 14.5 seconds. Okay? And that sign would be positive. That value of sine would be positive. So we have this interesting information that now we've done two things that we've not done before. Our sine can be taken when it's greater than 90, and then we also have that our sine value can be negative depending on if it's above or below our center. And then we have that the sine of the reference angle and the angle are the same thing, because when we did this, we got the same thing. Okay? So all of these are really important pieces of information that we have for what we're learning. We still have that symmetry that we can use with the idea of these four are the same, but when they're above, they would be the positive value, and when they're below, they would be the negative value. So those are the things that I want you to remember.